All right, let's just dive right into this explainer and demystify the invisible forces that dictate the prices of everyday goods. If you've ever stood in a store and wondered why the cost of your favorite products seems to just constantly fluctuate, you are definitely in the right place. Today, we're going to pop the hood and look at the actual mechanics of the market economy. To kick things off, consider these real-world mysteries from our sources. Have you ever noticed how some markets react almost instantly to changes, while others totally drag their feet? Like, why does the supply of massive container ships change so much slower than the supply of simple ballpoint pens when their prices change? Or why have calculator prices basically plummeted over the years, while the price of housing just keeps skyrocketing? Well, the secret lies in how quickly supply can adjust and the underlying conditions that are driving consumer demand. So, here's our roadmap for today's explainer. We'll be looking at 1. Why do prices change? 2. Drawing demand curve shifts. 3. Drawing supply curve shifts. 4. Reaching a new equilibrium. And 5. Consequences for overall sales. Let's get to it. Starting with Section 1, why do prices change? Before prices can actually change, they usually start out right here, in a state of market equilibrium. It's this perfect balancing point where the exact quantity consumers want to buy completely matches the quantity producers want to sell. In this state, there's absolutely no tendency for the price to move. It's totally stable. That is, at least until an outside force disrupts this balance and throws the entire market into disequilibrium. Okay, time for our first major mythbuster. When you're looking at price changes on a graph, you absolutely have to distinguish between a shift in a curve and a movement along a curve. This is crucial. An outside, real-world event, like, say, a jump in consumer income, shifts the entire curve to a completely new position. But if only the price of the product itself changes, that just causes a movement along the existing curve. It's an extension or contraction of demand or supply, not a shift of the underlying market conditions themselves. So what exactly are those outside forces? Well, they're the real-world clues, the non-price determinants that force our curves to literally shift. On the demand side, it could be a change in income. When people earn more, they buy more. It could also be the price of related goods. Like, if the price of salsa suddenly drops, the demand for tortilla chips goes up because they're complementary. Now, for supply, those shifts are driven by things like production costs, new technology, taxes, subsidies, or honestly, even the weather. Like if a nasty bug attacks a whole pea crop. Moving right along to Section 2, drawing demand curve shifts. If you just stick to this procedural, step-by-step checklist, I promise you will flawlessly interpret market diagrams every single time. First, always draw the original demand and supply curve so you can find your starting equilibrium. Second, identify the real-world event. Is it hitting the buyers or the sellers? Third, if it's an increase, shift the curve horizontally to the right. If it's a decrease, shift it horizontally to the left. And finally, step 4, find exactly where that new curve intersects with the unchanged curve to spot your brand new price and quantity. And this right here brilliantly illustrates the golden rule of economics. A rightward shift means that more is demanded at any given price, so an increase in demand. But a leftward shift, that indicates less is demanded, which is a decrease. Just remember, left means less and right means rise. It literally is that straightforward. To tie that up, this quote from our sources absolutely hits the nail on the head. When a variable that is not named on either axis changes, the curve shifts. Because price is on the vertical axis and quantity is on the horizontal, if something other than price changes, let's say a local public library closes so everyone has to go out and buy more books, the entire demand curve has to physically shift to a new position. All right, let's flip to the other side of the market in Section 3, drawing supply curve shifts. When we visualize supply, look closely at how it moves. If production costs suddenly spike, maybe a disease wipes out a bunch of potato crops, the supply curve shifts to the left. That means there's less quantity supplied at every single price point. On the flip side, if some amazing new tech comes along and lowers costs, the supply curve shifts horizontally to the right, meaning producers are supplying way more at every price. Okay, pause. We need to bust a massive visual misconception right now. Because a supply curve naturally slopes upward, shifting it to the right makes the new curve look like it moved down or below the original, and that visual trickery makes people mistakenly think supply actually decreased. No way. Never ever think up or down. Always evaluate on the horizontal axis. Left means less supply, right means more supply. Let's bring it all together in Section 4, Reaching a New Equilibrium. This is where you will literally see the invisible hand at work. Picture this. The market is just chilling in equilibrium, but bam, an outside event shifts the supply curve to the left. Suddenly, we're in disequilibrium. Consumers want to buy way more than producers are willing to sell at that old price. That creates a shortage. And what happens next? That shortage naturally drives prices up. And as the price rises, it causes demand to contract and supply to extend along their curves, right up until that shortage is wiped out and a brand new equilibrium is reached at a higher price. But, the real world is messy. Very often, both curves are going to shift at the exact same time. Like, what if the price of a substitute product rises, pushing demand for our product up, but at the exact same time, raw material costs plummet, pushing supply up too? Both curves shift right. The total quantity traded is going to absolutely skyrocket. But because increased demand puts upward pressure on price and increased supply puts downward pressure on price, they kind of fight each other. The result? The final equilibrium price might actually stay perfectly unchanged. Finally, let's look at why this matters in the real world in Section 5, Consequences for Overall Sales. As a business owner, you might naturally think, hey, if I just lower my price, I'll sell more and make way more money. Well, not quite. As we can see here, it's rarely that simple. It completely depends on the price elasticity of your demand. If your demand is inelastic, meaning your customers aren't super price sensitive, kind of like with gasoline, dropping the price actually won't increase your sales enough to make up for the cheaper price tag, so your total revenue actually goes down. On a flip side, what if you sell something highly elastic where customers have a ton of other options? Let's call it the Diet Cola effect. Here, your buyers are extremely price sensitive. If you drop the price of your Diet Cola just a tiny bit, it triggers a massive, disproportionate jump in the quantity demanded. In this very specific scenario, lowering your price will totally generate higher total expenditure and boost your overall revenue. So, I'm going to leave you with this provocative thought experiment to really test your new skills. If a breakthrough technology shifts the supply curve to the right, but changing consumer tastes make the product less fashionable, shifting the demand curve to the left, what actually happens to the final price tag? Does it rise, fall, or stay exactly the same? Next time you see a price jump at the grocery store or the gas pump, ask yourself, which invisible curve just shifted to make it happen? Thanks for joining me on this explainer, and keep your eyes open for the economics happening all around you.